Hello, everybody. Thank you for joining the Akasia webinar. Today's topic is how GCP is a good platform for your enterprise workloads. We will be focusing on the economics of the entire environment. I'm so pleased to have Miles Ward from Google joining us as a speaker at this webinar. In terms of our other speaker from Akasia, Garima Thockchom, he was unfortunately taken ill, so he's out sick today, but I will be presenting the Akasia material on his behalf. I'm Garima Thockchom. I'm the founder of Akasia Cloud. So with that, I'm going to make Miles a presenter, and we can get started with our webinar.
Thank you so much, Garima. I really appreciate it, and thank you, everybody, for joining up. Garima, if you want to put on screen the slides that we shared before, that'd be great. As a way of introduction, my role at Google Cloud is owning the global solutions architect team. That's the group of folks in our organization that connect with enterprise customers, help them think through the infrastructure and security and compatibility and technology choices that they have to be able to take best advantage of cloud platform, to be able to do the work together with our engineers and our operators to ensure that their implementations on top of cloud platform are scaled and efficient and secure and ready to meet the needs of their customers, and to turn those experiences, those connections with customers into great documentation and guidance and best practices for further future downstream users. That effort culminates in a set of materials that we publish at cloud.google.com/solutions that covers best practices and guidance and implementation patterns across a bunch of different verticals and covering many of the cross-cutting horizontal issues that affect every enterprise business. So if you look at cloud platform as a system, as an overall infrastructure designed to meet the needs of startups and folks that are working through the challenges of accommodating a mobile and machine learning first world, we really think that we've done a lot to set up an infrastructure that's designed to solve those problems. And the reason that we've done that is because we had to build one for ourselves. Google is itself a business that serves the needs of now across 7 of its products, 1 billion users or more across the planet. So there are 2 billion Android phones, there's 1 billion folks that interact with search, there's 1 billion people that interact with maps. If you're going to build applications that really represent the front of the business at scale, those kinds of applications require and have a standard of being enormously reliable. Customer trust and the customer respect for companies is really starting to come down to, how few times they show a 404 error, how frequently they're able to move through the interfaces that each of these companies expose with speed and ease. So if you're going to build applications like that, if you're going to power the internal applications of your business that frankly ought to have the same standards for reliability and performance, the systems that Google engineers use to build each of those products that so many people are familiar with are ready and available today as Google Cloud Platform for you to be able to do the work of taking existing applications and migrating them across, or building brand new applications designed following the best practices for public cloud. And what we're watching happen with enterprises is that as they look across the opportunity space and realize that, if anything, the rate of change is accelerating, and the amount of years that it takes for a company to get into the Fortune 500 is shrinking pretty dramatically. And the only corollary to that is that the amount of years that companies stay in the Fortune 500 is shrinking rapidly. So most businesses that are already there or are established in their mid-market or upper market spaces off of the stock exchange recognize that it's a pretty volatile time. And the differentiator between the businesses that we're seeing be successful and grow and the businesses that are failing to meet the challenges of our era is the ability to apply technology to the opportunities that present themselves. So our platform and our approach is to helping companies, big and small, legacy and non-legacy, folks that call themselves enterprise or call themselves startups, but sometimes behave like each other, to work with the newest tools and the best practices to build systems that will allow them to differentiate against their competitors, allow them to move forward in their individual markets and to capture whole new markets. There are a lot of businesses that are today really doing the work with us to, frankly, to bet the farm, to bet the future of their companies on the collaboration between Google Cloud and their business initiatives. A couple maybe easy examples. Take HSBC, one of the largest banking institutions in the world, absolutely a almost 100-year-old enterprise business, stewarding billions and billions of dollars in assets for across 100 countries around the world. A company like that, it may seem like that'd be a difficult business to entertain the complexity and the newness and the sort of perceived challenges of taking applications and moving them to public cloud and taking advantage of the alacrity with which you can build applications in public cloud. They've jumped in with both feet and are, rather than sort of starting with the move of old applications or migrating off of old platforms, have started right at the top of the value chain with machine learning technology used to improve their fraud detection, improve their ability to project financial liquidity, which is a regulatory requirement for them, and a host of other analytical challenges that have proved really vexing for folks that work in those areas and only have access to things like applied statistics and regression models. Machine learning makes that stuff much faster. So for them, there are already very material, positive financial ramifications of the partnership together with Google Cloud Platform and its supporting engineers and professional services teams and broader systems integrator ecosystem. So that's one example, an enterprise company pushing off into the future of technology for their business. We've got other companies for which the operational load of the existing software they ran was so overwhelming they needed to migrate in structure. So we worked together with the folks from Home Depot, absolutely a long-standing, totally visible public brand. I don't know anybody that doesn't know what the orange square looks like. And their core application interface for understanding data was built on a legacy data warehousing provider that was too slow and too expensive and not able to meet the rapidly accelerating growth of their web presence in competition with other online retailers, as well as the integration of their web presence with their in-store experience. And so that data warehouse was a crippling element of their architecture. And they looked at services from Google like BigQuery, where there is an absolutely unlimited scale to your ability to do analysis. We demonstrate in our sales calls petabyte queries, where the system that they were using was unable to scale for any production customer above 100 terabytes or a tenth of the size. So that kind of scale and speed and dynamic access, where they were able to, at the call of an individual query, have as many of the Google machines around the world work on processing their data on demand and pay only exactly for the compute infrastructure that they consumed during that query, was revolutionary for their ability to add analytical performance and speed to the applications that they built. So you can see that there's examples in both legacy applications, some of them moving into new Google tools. We have other customers that are taking existing applications and just moving them exactly unchanged into our environment, stuff like SQL Server database-based applications or stuff built in Java or .NET, folks running Windows and Linux. The platform is very flexible, and its virtual machine infrastructure creates a compatibility layer to a huge swath of the existing enterprise infrastructure or legacy that by moving into a public cloud infrastructure, you take advantage of our security profile and our capacity planning and our network performance and our work at constant improvement and innovation around the behavior and performance of the resources that support all of these kinds of initiatives. So for our customers, as they move lift and shift pieces across, they may not get, and this is just being direct, they may not get all of the benefits of an application that is designed from scratch to work in the most modern paradigms of microservices and serverless architectures and containerized applications. But they get a very, very big boost in performance and security and cost efficiency in comparison to running this stuff on your own in a private data center where you're totally responsible for the full scope of the stack. I'll pause there. Garima, were you able to pull the slides that I described and get those on screen?
Mm-hmm. I was. When you're ready to show your demo, let me know and I'll switch over to your screen.
Well, let's go through these slides now, and then we'll switch to the demo. So, and maybe back up 2 slides for me. I want to describe the infrastructure that we're talking about first. Back. There we go. So, one more, please. So the system that I'm going to describe to you is an infrastructure built by Google for Google's use. It is the system that we use to best serve customers around the world. It is one of the largest, if not the largest, compute infrastructure under management by any entity. The lines across the screen here are compose an international global network operating at over a petabit a second bisectional bandwidth. That's sort of a technical term. What it means is that we have a network carrying over 5 times as much data as this other network you may have heard of called the internet. So our systems are much larger and operating at much higher scale than the systems that power all of the rest of the internet. And as a result, the applications that you build inside of us instantly have access to infrastructure around the planet connected by our own totally owned private fiber network. This is a huge security differentiator in that there isn't any component in the application framework that you use when you run on top of us that isn't owned by Google, managed by full-time Google employees, not contractors, and secured by end-to-end encryption, many of the technologies for which were invented here at Google. So if you want to go on to a couple slides down, if that sounds expensive, it is. We spent about $30 billion building the thing over the last 3 years. And the result is that when we talk with customers, they're finding that the results speak for themselves. There is just a clear performance and availability benefit and the experience of developers as they move either from enterprise environments like Lush, who was moving from a private data center, or like Quizlet, who was moving across from another cloud provider. They're able to see market performance improvements and market cost reductions, even while the experience is pretty easy to do, right? If Lush was able to literally move the entirety of their technical infrastructure, all of the things they do with computers where someone isn't touching them with their hands, into our environment in less than a month, I suspect there is an enormous opportunity to capture value for a lot of our enterprise customers. Do you want to go on to the next slide, please? So the challenge we run into, and I've been working in public cloud now for just coming up on 10 years, is that there were a set of original ideas. These ideas about what cloud meant as a value proposition into enterprise users. And a lot of those were contrasts with the frustrations or the challenges of the existing sort of cyclical procurement-based model for consuming infrastructure. In a lot of ways, these kinds of systems are designed to mirror the advantages of SaaS businesses in charging you monthly for what you actually use, as opposed to charging you a license that you're responsible for extracting value from. So we think that the economics of every cloud provider should benefit customers and are designed in a lot of ways to more narrowly track the actual usage and the actual need that you have as a business. And what we found is that the reality is that's changing. So if you want to go on to the next slide, As the public cloud competitors have grown, turns out that they've started to fold backwards into the kinds of models that enterprise procurement folks in a lot of cases are more familiar with. So some of it's about comfort and familiarity, but some of it, frankly, is about padding the bottom line of the larger infrastructure providers and making sure that they're able to retain customers and lock them into financial contracts that ensure repeat business. And none of that, to me, sounds like public cloud. What I signed up for was you use only what you need and you pay only what you're using, and things are very flexible and dynamic. And if your usage grows, it grows, and if it shrinks, it shrinks. We're here to serve exactly what you need. And as cloud has deviated from that, I think it's gotten less valuable, and less valuable in a particularly painful way, in that it has taken power from the enterprise buyers and procurement folks and pulled it back over. And so I think a lot of the goal of the design of the economic system inside of Google Cloud is the opposite, is to push power into our buyers, into our customers, because we think with a little more power they can do incredibly powerful things. If you want to go on to the next slide for me. So across a couple of different analyses, I think probably the most pointed was from RightScale. We were able to show that the inflexible components of our competitors have a tendency to drive pretty substantial waste, right? If you only need a computer for a couple of minutes, but things are being billed by the hour, if you're forced to use machines that are larger than you need to get the resources that you want, if you're signing up for 3 years for a project, you don't even have the budget assigned for the year after, things can get complicated, and that has led to quite a lot of waste. So our model is to eliminate that waste for enterprises, to make it so that you pay just for what you use. You want to go on to the next slide. The first of that is looking through exactly how you pay when you have this variance between some applications which are truly on demand or computer controlled, automatically scale and slide up and down to accommodate load. Other types of work aren't that dynamic, right? I don't know anybody who turns off the front of their website when no one's looking at it. You got to leave that thing on no matter what. And so if you have systems that are running 24/7, a lot of other providers gouge you because there is a cost on our side to turning things on and off and adjusting the way the network behaves to accommodate new resources. If you're going to leave a system steady state, it's cheaper for us to run, so it should be cheaper for you to buy. In our infrastructure, you get automatic sustained usage discounts. So any system that runs more than a quarter of the month, we start giving you a discount on the purchase price all the way up to 30% off of the pricing on those machines. That's worked out to an average for our customers of about a 24% savings over what would be a standard bill. And that's not an opt-in. You don't have to poke the right button. There's no negotiation with the salespeople. You literally cannot screw it up. So this kind of automatic, built-in best behaviors is the way that we've heard from customers. They really want us to serve them. Maybe the next slide for me. Another place, if you're going to build a cloud tomorrow, you're going to buy computers and you really want as many of them utilized as you can. And with inflexible last generation virtualization technology, it can be really difficult to efficiently grab the resources across a big fleet of infrastructure. So they tend to sell virtual machines in fixed sizes. And that means that if you need 18 cores, but they only sell either 16 or 32, guess what? You're going to buy 32. And that means there's a whole bunch of waste in the systems that you procure. Go down to the next slide. On our infrastructure, because we're built on a more modern, containerized underpinning a system called Borg, which controls all of Google's infrastructure tools. You can tell we're dorks when we name stuff after Star Trek. So that allows us to create totally custom machine types. You tell us how many cores, how much memory, down to the quarter gigabyte increment, and we'll make it so that it fits exactly what your application needs. Next slide for me. Turns out a lot of people said, like, I don't know. How do I know what my application needs? I mean, it comes with a manual that says this is what the minimum requirements are, but then every time I log in and look at the performance counters, the CPU utilization, it doesn't seem like it's all that high. How do I know what the right size is? Conveniently, we just sort of built that in as an automated feature. We'll tell you exactly what the right size for those applications is based on observing them over time. And rather than make you tear them down and relaunch them and do a whole bunch of extra work, you just click a button and we resize it to that size. So super easy, super straightforward way to make a system dramatically more cost efficient at exactly the same performance level, because we know for sure that you're not using those resources that you're leaving on the ground. Next slide for me. We've also moved to super granular per second billing. That means that anytime you turn a computer off at 4 hours, 15 minutes, and 32 seconds, you're paying exactly for those 32 seconds. Now, the little tail end there, that's kind of a rounding error difference in cost when you're talking about long-running systems. But when you're running automated dev and test, automated continuous integration and continuous deployment, a lot of the design patterns call for virtual machines that run for relatively short periods of time, sometimes on the order of seconds. Right? If I can boot a virtual machine in under 30 seconds, which Google Cloud Platform is far and away the price and performance leader, we're able to do that faster than most. We also charge you only for the actual seconds that you use. So those kinds of automated, programmatically managed applications become dramatically less expensive as you boot on and off, on and off, on and off machines around the world. Next slide for me. So you take all of these benefits together, and it's not like coupons at the store or something. They actually stack. Those are cumulative benefits. You can apply those to everything. They're automatically included. And we have models for systems where you truly need long-term commits on infrastructure that allow a super flexible discount called committed usage. We have preemptible virtual machines that make it so that if you know you don't need to keep an analytics or data processing application running 24/7, we can cut 80% off of the cost of VMs. There's lots of additional tools. But in sum, the folks at Cloud Spectator and several other benchmarking groups have done the look of the combination between our performance advantages, which are pretty marked, and our cost advantages, which are also pretty marked, and found that we absolutely set the bar. We are, out of their 0 to 100 score, we are the 100 in terms of best price performance delivery for applications that are brand new, like startups, and legacy lift and shift workloads from enterprises. And the ratio of price performance varies. It's not like, there's a 10% difference between them. It's a factor of over 2 between us and our competitors. We're watching very regularly, for Amazon Web Services customers, as they move across to us, seeing a pretty typical 40% average reduction in their bill. And I know a lot of the folks on this call would describe their businesses as above average, so I think you can save even more than that. If you want to go, I think there's maybe one more slide in this, and I think we should switch over to the demonstration stuff on my side. So those, if that's the cost systems on our side, and there are, again, a huge number of products in Google Cloud and really a rich set of services. It's hard to summarize an application environment that's used to build so many widely varied businesses, and we'll be able to see a little more detail in some of the demonstrations that I'll do, but I think that gives a little bit of a view into the kinds of benefits that enterprises can expect from moving into our public cloud.
Okay, so I'm going to switch over to your screen now, Miles.
Okay, sounds good.
Here we go.
So one of the tools that we built, because anybody that's in an enterprise that's trying to figure out how to work these kinds of new platforms and new tools into their friends and partners in procurement and finance planning and the office of the CFO, not just the CTO, we built a tool. I actually designed the tool, a thing called the Google Cloud Platform Pricing Calculator. And the calculator is a tool for taking workload items, infrastructure, or any of our different product systems, and estimating what those kinds of tools will cost in practice. So let's use the examples we were using before, virtual machines. Our product for virtual machines is called Compute Engine, and it's the first thing that you see in our pricing calculator. The way the calculator works is you tell us how much stuff you're going to use on the left, and we tell you how much that's going to cost on the right. So what we hear from a lot of customers is, how do I know how many computers I'm going to use? An easy place to start, if you haven't done this kind of work before, but you have an existing application, is to take the bill of materials that you use for your current systems and copy them into us. Now, what I'll tell you is because our stuff is a little bit faster, in some cases you can be more conservative in your design on us than you would in your own environment, because we're, one, able to help you grow on demand with no real latency there, and two, we are just a little bit faster. But for the first step, in most cases, most businesses estimate at 1-to-1 and then do performance testing after the first month or so of their operations on top of us, or maybe as part of a proof of concept, and they'll pretty quickly get to the ratio between their actual hardware today and their future hardware in Google Cloud that will allow you to adjust these kinds of values. So let's say, for example, we're going to build a web application, and I want to have 3 virtual machines for my web front end. And I can use any of the different operating systems, both free and paid on us. Say I'm going to build this on top of Ubuntu. I also have choices around the class of virtual machines, so that's whether they are on demand and on forever as long as I need them to run, or preemptible by Google. Remember, that's an 80% discount if you choose that way, but it's really only a model designed for systems that are programmatically controlled, computer controlled, to be able to do distributed processing or other kinds of work. You also get to pick the instance type, and we do have named sizes. It's easy to just say, well, I always want to use N1 HIMEM 16s. That's exactly the right size for me. But if you have a more specific workload, you can create a custom machine type. So you could say, I want 28 cores, and I think the right amount for my web servers is 98 gigabytes of memory. You see how flexible that is. You can pick anywhere in this range. Maybe it's much more efficient for you only to have 37 gigabytes of memory on your machines. That's not a round number, but it might be what's actually most efficient for your systems. So I've chosen down here to run in Iowa, but I also have access to infrastructure across Northern Virginia, Oregon, Belgium, London, Frankfurt, Tokyo, all around the world. So let's say I go to Northern Virginia and I want to run that machine 24 hours a day, 7 days a week. But those are our web servers. We're going to leave them on. If I add that to the estimate, you can see a total estimated cost. That includes our sustained usage discount. Remember, these machines are automatically discounted if they run 24/7 for an effective hourly rate of 86 cents an hour. And those are pretty beefy machines. So it's a very efficient price point. You can save that estimate or email it to your peers and get a good idea of what that looks like, not only at a 1-month view, but even if you ran that as a test just for a day, that's only $62. And again, that's a monstrous infrastructure. But that's just compute. You also, of course, would want to estimate how much network attached disk you want to use, what kind of load balancing you need in front of those applications. And we also have a whole huge suite of products, right? If you're building an analytics service, you'd use BigQuery and say, oh, I'm going to build a database called My Customer Data, and the storage I'm going to have is 100 gigabytes, and I'm going to do 2 terabytes of queries across that. That sounds like a pretty beefy data warehouse. Note that costs 23 cents to run on top of us per day. So that's pretty expensive. I run that over a month, it's a whopping $7. So recognize if you have applications that are designed to run in virtual machines for which we have managed services, in some cases they are dramatically more price efficient than doing this stuff kind of the old school way. And there are products not only for infrastructure services like that, but also APIs for machine learning. Like, I want to be able to tell what's inside of pictures. Is there explicit content in the images that are being uploaded to our website? Are there any people's faces? What landmarks are in the back? We have a whole huge set of natural language processing, so you can unpack, what is the sentiment of posts that people are sending in. You can build global databases and do genomics research. There's really a very rich platform, and all the way up and through our support and professional services offerings, right? If I don't know what any of this stuff means, and I just need somebody to come out and tell me where I get started and how I'm able to capture the best value, I say, well, I want an infrastructure team from Google to land at my offices and help me think through the replatforming of the future of our business. Let's add that in. That's a consultancy engagement from us that cost $50,000 to have a team from us come out and do that work with you. So this environment allows you to pick and choose the building blocks from Google Cloud and figure out what it is that they'll cost. If you don't know which building blocks you need, we've built another project, a thing here called the Treehouse. And this is something we're working on right now, so there may be some funkiness. But if you look at the buttons below, there are architectures across different industries and sort of cross-cutting horizontal requirements that customers have that we've built patterns so you can see the kinds of building blocks that make sense on our side. So like if you want to do something like content hosting in an environment or maybe mobile site hosting, this is the architecture on our side, the building blocks that get used to take and build a highly efficient mobile site. You can use App Engine for a backend, you can use Firebase as a persistent real-time data store, and you can use Compute Engine as a backend processing application to offload work from either of those two services. If you're interested in doing work in a specific vertical, say you're in media and you have to do rendering and maybe even live streaming of video down to customers, here's an architecture for that. You build streaming servers in Compute Engine. You're going to need to store segments in our cloud storage service. Maybe you even use some of our partners, either CDN or our on-BART CDN. If you're interested in technology partners or services partners that are working on these kinds of things, we have a partner listing here at the bottom as well. So really a useful interface to say, well, okay, I need a little Compute Engine and I need a little storage. Let me go back to the pricing calculator and type in those resources to pull together an estimate of what my infrastructure needs might be. Hopefully that all makes sense. I'm more than happy to answer questions about it in the back half of the interchange, but really that's what we've got. So hope it all makes sense.
It does. It does. Thank you so much. In fact, we have a question that I think you can answer right now from Darlene, and she asks if she can get access and how can she get access.
Both of these are totally public, free websites as a part of Google Systems. So the first is cloud.google.com. You can see it on screen, /products/calculator. You can also navigate to that if you want. If you go just to cloud.google.com, it's available through our list. The other project is a thing called GCP.solutions. Now, that may seem like a weird domain name because there's no like .com or .net, but it turns out .solutions is now a top-level domain. So you just type GCP.solutions in and it works. So both of those are freely available on the web.
Fantastic. Hey, thank you so much. What we're going to do now is go ahead and do a quick poll. They're thinking about GCP for migrating existing workloads or for deploying new applications, or for both. So let's see. So far, 60%. Okay, I think we're done. Go ahead and. Okay, so as you can see, this is very interesting. 60% are migrating existing workloads and 40% are doing both. So this is a trend that we're seeing over and over where there seems to be an emphasis on migrating existing workloads for various reasons. Fantastic. That's actually a good segue for me to talk about our company, Akasia, and what we do. So we're a 3-year-old company. Our headquarters are in Santa Clara in Silicon Valley, and our engineering team is in Pune in India. We are venture-backed by Thai Launchpad as well as a couple of angel investors. We are all about helping enterprises transition to the cloud. When you think about enterprises, you know, the early adopters, the developers and some of the early admins, they began to use the cloud early on, running transient applications, small test environments, etc. But over the last year in particular, and I would say in the last 2 quarters, we've seen a huge emphasis on looking at existing data centers, legacy applications, complex applications, and enterprises are now thinking about how do they move those environments to the cloud. Now, when they're talking about moving those environments to the cloud, they're thinking two things. One is lift and shift, and the other is refactoring. So if they're thinking lift and shift, which typically a lot of them start with, and they end up refactoring a few or part of the applications. When they're thinking lift and shift, they're answering these three fundamental questions that are on the screen. Examining what they have on-prem and mapping to what could be the equivalent environment in the cloud, and figuring out what else is needed to build out their infrastructure in the cloud, additional cloud services and so on. And then they are trying to put their arms around what the costs will be, and will they really save costs. So there's an interesting dichotomy that we've observed between CIOs and users of the cloud architects and so on, where the CIOs are really interested in knowing what the cost will be ballpark. And the administrators are convinced that it's going to be simpler, quicker, cheaper, and they want to move to the cloud and figure it out. Whereas the CIOs sort of hold back the project and say, no, let's figure out the cost. Now, I do want to say that a lot of the CIOs are not cost sensitive, as in they will frequently pick a more expensive destination compared to a cheaper destination, but they want to know what the ballpark will be. Now, those are the questions that we help provide clarity on. So we help enterprises as well as SIs determine what would be needed to replace the on-prem within cloud, what else is needed to build out the hybrid infrastructure, and all the costs associated with the major public clouds. And here I want to pause and say, even though we've noticed that there's been a normalization of pricing across all the different clouds over the last year, in big part helped by our tool where we began to show costing for the same environment across different clouds. What we have observed is that enterprises do want to know what the costs will be for another cloud, just to feel that they have vetted all possible options. Now, the advantage of using our tool is that we're able to do the discovery as well as the mapping very quickly in just 30 minutes to a few hours. And this is why we're seeing a lot of traction with SIs who sit down in a pre-sales conversation, bring up our tool, and quickly do the costing and mapping to provide their client with a sense of what the costs will be. Even though everyone's thinking, all the enterprises are thinking about migrations, what we're finding is that the conversations are endless. It takes 6 months, a year for a client to just be in the exploratory stage. And that's where a lot of SIs that we partner with have found use of our tool, where they bring in our tool and they are able to hasten those discussions and move them towards whether or not that client is going to migrate or not. So a quick view into exactly what we offer. We have 2 SaaS solutions, and we also offer consulting services. So the 2 SaaS solutions are modeled for the 2 use cases that we are seeing clients indulge in. The first one is for lift and shift migrations. And this is where our tool does the discovery of the on-prem environment, where we look at the configuration as well as the usage, and then we show you the equivalent as well as right-sized cloud templates in minutes. And these are templates across all the different clouds. One important feature of our lift and shift product is that we also include hidden costs such as network and I/O. There is a perception and there's a bit of a scare out in the market that you do some costing initially, and then when you actually move the application, you're hit with these surprise costs, and where did those costs come from? We've discovered that it's usually network and I/O to blame. And so what we do is we make sure we discover those items and also cost out for them in the cloud, so that there are fewer and fewer surprises as you're doing a lift and shift to the cloud. Now, the AIM report gives you a cloud bill of materials and the costs And this forms a starting point for your migration. And I'll be giving a demo of AIM right after the slides too. Our second product is ACM. Like I was mentioning earlier, and Miles mentioned it too, there are a lot of strengths of cloud-native resources that you cannot find if you're just doing a bare lift and shift. And we found as we continued with our conversations with clients that refactoring became an option as they followed through in their cloud planning. And so what we did was we built a second SaaS solution that we're calling ACM, the Akasia Cloud Modeler. And what it does is it allows you to select and configure cloud-native resources, and then in the end you get a list of resources across all these different clouds so you can compare which could be the most optimal destination for you. And I'll be giving you a demo of ACM as well. Now, Cloud Transition Services, we started off as a product company. That is our heritage and our expertise. But we found that more and more of our clients were coming back to us just because we've developed so much knowledge of cloud resources over the last 4 years that now we've formalized our Cloud Transition Services into several options. We can do the entire transition for you. That includes the discovery as well as the planning and migration. Or we can just answer questions for you so you can buy our resources hourly. So these are our ACEs, or our Akasia Cloud Experts. So these three are our offerings, and we'll be talking a little bit more about them. Really quickly, our users are both end users as well as pre-sales people, pre-sales and the cloud vendors as well as SIs. And our advantages, like I mentioned earlier, are that we can build bill of materials very rapidly. And so you can build rapid proposals, you can compare across cloud vendors. The other advantage is you get a deep insight into the customer's infrastructure or your own infrastructure. So where you may be thinking of migrating just, say, your SAP environment, when you do a discovery and analysis with Akasia, you find out that there are other applications that are migration worthy as well. So you get more intelligence about your infrastructure. Moving on. These are some of our customers and partners. Now, as I mentioned earlier, we do partner with a lot of SIs, and among them are some of the big heavy hitters, IBM, Wipro, etc. IBM Global Services, which is cloud agnostic, uses our product pretty heavily. And then, as well as Wipro, we have some mid-range SI partners as well, so Poleo Systems, Base Farm, CompuNet, etc. We have a huge smattering of end-user customers also, so Apache, Havberry, Paperclip, Acadian. These are folks that had on-prem infrastructure that they wanted to figure out what the cloud costs would be, and they bought our licenses and used them. Now, the problem we solve. So cloud cost forecasting is complex. There are many resources that you can pick from. There are many pricing combinations you can pick from. And what we found was there was a level of anxiety among the enterprises. They kept feeling that they were missing out on some other option that was perhaps more suited. And when they run our tool parses through all the different permutations and combinations and presents a number of options that the client can pick from. And we also allow for what-if analysis. So you could override some of the recommendations that Akasia is making and come up with something that's custom for you. So once again, we do right sizing and what-if analysis. So right sizing is not just downsizing your environment, but it could also be getting a bigger environment. So we are able to intelligently look into your environment and see if it's overcommitted. A lot of VMware environments are overcommitted. And then if we detect that, your storage is maxed out, then we recommend a higher level of templates for you as a safer option. We also downsize the environment. So, if we notice that your environment has been underutilized over a period of time, then we let you know that there's idle capacity in a certain set of VMs, and you can right size to the recommended template that we provided you. So several options here. And in addition to just right sizing and parsing through hundreds and thousands of permutations and combinations, we also include the cloud pricing options. So like Miles was talking about, sustained user discount, custom templates, predefined templates. We offer you all of those so that you can pick the one that's the most suited for you. How AIM works for lift and shift, I was mentioning earlier, it's a simple three-step process. The first step is we discover the on-premise environment. And the second step is we show you the mapped right-sized environment and then in the cloud, and then also allow you to do what-if analysis. And finally, you can flesh out the environment in the cloud of your choice to come up with your closest, most granular cloud cost estimate. Quick note on discovery. There was a time when discovery was a solved problem, but with the advent of cloud, not anymore. We offer two kinds of discovery solutions. One is quick discovery, and this takes just a few minutes. And this works for VMware environments, Microsoft environments, and as well as physical environments. So our discovery tool just latches on to the management console, sucks out the data that we need to do our mapping, and then within minutes provides you with the equivalent mapping. We've had environments where the customer had thousands of VMs, 5,000 VMs, and our discovery tool took just 12 minutes to suck all the data it needed. So this is why, within minutes you do get a close granular sense of what the cost will be. Now, there are environments that are complex, that are getting ready to do a migration, and they typically use the Akasia Deep Discovery. And this takes hours or days, depending on the extent of the discovery being done. And here is where we look at more complex dependencies, application mapping, the network analysis, and so on. So our deep discovery is a combination of using existing discovery tools as well as our own IP there. So two options that you have for discovery. Now quickly about our architecture. So because we are cloud agnostic, we have on the upper level of our tool collectors that suck in the price book data from all the major clouds. And with the exception of Oracle that doesn't have an API yet, we have written collectors to all the APIs of the major cloud vendors. And we refresh our database once a day. So you always have the latest pricing within the Akasia tool. On the incoming side, as in the on-prem side, we have a collector that sucks in the data of the on-prem environment and pulls it into our normalization cost calculation engine. And so this is how we're able to pull data from all the different environments and then provide you with the normalized cost option. We also have public interfaces that a lot of our partners use to white label our product, as well as to suck in our calculations into their own tools that do a higher level capacity planning, etc. So with that, I am going to get into our tools and give you a sense of our products. All right, so when you log into our dashboard, you're presented with our two offerings, AIM and ACM. AIM is for lift and shift migration planning, and ACM is for new cloud deployment planning. So I'm going to quickly go through AIM. So here you would discover your on-prem environment either by downloading the remote collector or by using our VApp tool. Our remote collector and our VApp tool creates these CSV files, which you would upload and give and non-VMware environments that include Microsoft, KVM, physical environments too. I apologize for that. Okay, so now once you've uploaded the environment, you can go ahead with your cloud planning. So here I'm going to pick, you can pick, among all of the environments that have been uploaded. So this environment that I've ingested has 8 hosts, 109 VMs, of which 99 are on, 10 are off. And here is the breakup of the costing across the different clouds. And one of the things that we've discovered pretty consistently is that Google is the low-cost leader for various reasons, but one of the main reasons being their custom cloud templates, as well as the sustained user discounts. So this is giving you a high-level sense of where the costs land in terms of the different clouds for this environment if you were to move all the environments to the cloud. But you probably want to do more granular costing, so you're looking into either moving certain hosts that are being end-of-lifed, so you can pick by host, or moving certain VMs that are running certain applications. So here you can do a search by applications and pick just those VMs. There you go. What I'm going to do is just pick the VMs that are on, so give you a good flavor of the entire environment. So I'm going to pick all the VMs that are on, add them to the modeling group, and then say compare cloud estimates. So for my 99 VMs, this is my cost breakup. And here I'm showing you the right-sized cost. You can also take a look at total as-is cost. So this is, not right-sizing, but migrating as-is. We also show you breakup of compute versus storage versus network and I/O. And this just leads to some interesting insights where, you may find that for your set of applications, if they are high compute, it may make sense to move it into one of these clouds that, has lower compute cost. And if it's high storage, you want to stay away from those cloud vendors that charge pretty high for storage. Some interesting insights here. And then as you scroll lower, you see more and more detail about all the cloud providers and their different cloud pricing options. And because we are doing a demo of Google, I'm going to jump into Google Predefined, and I'll select this card. And now here we go. We see more detail of what it's going to cost you to run those 99 VMs lifted and shifted into Google Cloud. For those 99 VMs, our tool has mapped to the closest equivalent here and the right-sized equivalent. If you're wondering about how we came up with these options, you can look into the configuration area, and this shows you what we've discovered in terms of usage. So for example, in the first environment here, 2 vCPUs, of which both vCPUs are being utilized. Storage, we've allocated 114 gigs, but only 37 gigs are being utilized, and 7.5 gigs of memory, and only 1.8 is being utilized. So there's some idle capacity here, extra capacity that can be right-sized. So that's how we come up with right-sizing options. You can also override these and come up with your own, pick your own template that you would want to use. I'm just going to go back and show you the custom environment for Google. Google Custom here. So as Miles was describing, Google Custom templates are where you build them out. So you're pretty sure there's no extra capacity. So you actually build out the size of the template based on CPUs and memory. And so we've mapped the environment to the closest custom templates. And this, again, is a unique differentiator that Google has. With all the other clouds, you're given cookie cutter templates, and they may not always fit in terms of CPU and memory, so you have to pick among them. Anyway, so now we're going to go order additional cloud services. So like I was mentioning earlier, the entire price book of GCP is in here, so you can add additional resources that you would need, so maybe Cloud DNS, Perhaps you need some prediction. Prediction is App Engine. Support. You should be ordering support, etc. So you can order any additional resources that you need to build out your 99 VM environment in GCP. And so we've added that here. You can also vary the quantity there. And now go on to adding other costs. Because we're a holistic costing tool, we also include migration costs. So this will be something like, let's say about $10,000. Perhaps you're paying for our tool. Maybe you're paying for network access given you've moved your applications off-site. You've had to hire some GCP trained admins, so you can factor that cost in. And then proceed to Cloud Report. Here we go. So for your 99 VMs, this is your on-prem configuration. This is your on-prem cost. And then you can compare the on-prem cost with the different options within GCP. And for this particular environment, a GCP is more inexpensive compared to on-prem. And as you scroll lower, by the way, you can also add any discounts here. You know, a lot of cloud vendors offer discounts, so you can factor that in. And as you scroll lower, you get to see more and more of the breakup of the costing, more granular details. So this is the total monthly cost, advanced services, network, storage, compute, etc. Clearly, you can see your right size savings here. So we do show you for both custom and predefined. Then as you scroll lower, you will see the sustained user discounts as well. This is your VM configuration for all of your 99 virtual machines. And now here you come to the bill of materials. So for the 99 virtual machines, we're showing you side by side what your GCP template will be. So you're ready for your lift and shift. Here are the additional services you've ordered and your other cloud costs, your one-time costs, and then a breakdown of your monthly costs with sustained usage and also 1-year committed use and 3-year committed use. You can export this plan. You can export it in a spreadsheet or a PDF, and you can also save the project and come back and edit it later. Now, everything that I showed you so far is our live product. So it takes you exactly this amount of time to do your modeling. So this is our first product, AIM, that is for lift and shift migrations. I'm going to quickly show you ACM, which allows you to refactor to a brand new environment in the cloud. So all the different cloud options are listed here in our product catalog, and you can go ahead and pick whatever you want here. So perhaps you want to pick container management, maybe serverless compute, perhaps analytics and big data. So you can select everything that you want and then go on and configure it, very similar to any other cloud calculator here. So we're going to say 4 nodes. Machine type will be, say, compute optimized. Let's assume it's HPC. Container management, say 10. And we offer helpful hints throughout our tool here. And then for serverless compute, let's put 32 gigs of memory, 10 seconds of execution, say 1 million executions a month. And now we hit compare products. And now here you see for the environment that you're thinking of building out, brand new environment in the cloud, these are the different options in the various clouds. So you can again download these as PDFs or spreadsheets and work on them some more. So very simple tool, and the example, the advantage of this is you are able to compare all the different options and therefore take advantage of the native resources in the clouds. Now, with that, I realize I'm a little over, so let's take a quick look at questions and see if there's anything we should be answering. So a question here that applies to you, Miles. The question from Darlene is, what if I already own my software? Can I upload that to the cloud? For example, if I have an SQL Server license and Windows OS, do I need to repurchase those apps?
Sure. Every different software vendor has their own rules and constraints in their contracts. So it's important that you review the specific contract that you've signed with your vendor to ensure that you're able to do that kind of thing. The good news is the vast majority of software is something that you can move unchanged from one environment to another. Remember, for most companies that sell software, today they're monetizing by the number of computers you run it on. So you may end up in a situation where you're paying for some extra licenses during the transition while you're running in both places to test. The good news is a lot of software packages now are available on demand from our environment. So things like SQL Server and other components of the Microsoft SPLA licensing catalog are things you can rent just for a couple of hours while you do a test, and then move your licenses across using the using those SPLA controls. For Microsoft specifically, and there are again variations of this pattern across different vendors. The individual software applications that run above Windows are ones where your licenses can be ported. That's a Microsoft license portability program, and it's an offer as a component of your enterprise agreement. There's details available on our site and theirs to show you how that works. Windows operating system licenses, because of the way that all virtualization vendors manage core infrastructure, are not portable today, specifically for Windows Server licenses. So it's important that you plan accordingly and make sure that you use our SPLA licenses to run that software and diminish the requisition on your side for direct purchases on Windows Server over time.
Got it. Thank you so much. And with that, we are 5 minutes over, but that's to be expected given the rich content we covered. Thank you so much, Miles. We really appreciate your taking the time to give us the exciting updates on Google, and we'll be in touch with all the attendees and make sure their questions are answered, and I'll also send you all the recording of the webinar. Thanks so much, and with that, we are concluding this webinar. Bye-bye.